Now we're going to talk about solutions, specifically aqueous solutions. And what does aqueous mean? Whoops. Water. Okay. So that means we are dissolving something in water. A solution is a homogeneous mixture. So whether we're dissolving a solid or liquid, once it's dissolved and mixed, it looks like one thing. Solutions are composed of two things: the solute, which is the substance that is dissolved in the water when we're talking about aqueous solutions, and the solvent, the component or substance that's doing the dissolving. And when we're talking about aqueous solutions, which we will be, that is water. Solvents are typically present in larger amounts. And the solutes are, in general, present in smaller amounts. Okay? And this just basically says the same thing. Water is going to be our solvent here. Now, the reason we're discussing this now is because we need to talk about electrolytes versus non-electrolytes. You'll be doing a conductivity lab in a couple of weeks, and it's important you understand what happens to substances when they dissolve in water. Okay? An electrolyte, when dissolved in water, produces a solution that conducts electricity. In order for that to happen, there have to be ions in solution. Example here, sodium chloride dissolved in water. It doesn't remain as a crystal. It dissolves, and when it dissolves, it separates into its composite ions, sodium ions and chloride ions, and that's what enables the conduction of electricity. Non-electrolytes, on the other hand, do not conduct electricity because they do not produce ions. Rather, they dissolve as a discrete molecule. And the example given here is sucrose, or sugar. When we dissolve that sucrose in water, we still have sucrose molecules, no ions. Therefore, it does not conduct electricity. And in the conductivity lab that you perform, you will be comparing conductivity of two electrolytes and one non-electrolyte. Now let's talk about some other terminology that describes what is happening when something is dissolved and forms ions in solution. Dissociation is a term applied to ionic compounds that separate into ions when dissolved in solutions. And again, here's our sodium chloride example. Versus ionization. This is the formation of ions by molecular compounds when they're dissolved. So even though sucrose was a molecular compound, it is not capable of ionization, whereas something like HCl, a strong acid, is. And so when HCl dissolves in water, the chlorine atom, and if you recall, this is what HCl looks like, and even though we haven't gotten to this topic yet, This bond is formed by the sharing of an electron from hydrogen and an unpaired electron from the chlorine atom. And when this dissolves in water, the hydrogen's electron goes with the chloride ion. So we get an ion that is negatively charged, and hydrogen is now without its original electron. Another example of that is ammonia, which also is a molecular compound, covalently bonded. So hydrogens are sharing one electron with nitrogen. But when it dissolves in water, because nitrogen has a lone pair of electrons here, one of the hydrogens in that water gets attracted to that pair of electrons, and thus we get the ammonium ion and the hydroxide ion. So ionization is different from dissociation. Remember, ionic compounds are made up of ions. Molecular compounds are not. So we can also classify electrolytes as strong or weak. If we have a strong electrolyte, it dissociates 100%. And that means that there are no original formula units left. So when we use that sodium chloride example, the only thing we have after the dissolving process are ions. There is none of this left. So strong electrolytes are water-soluble ionic compounds and strong acids and bases. Strong acids are going to ionize, not dissociate. Weak electrolytes, on the other hand, only partially ionize in solution, and these would be weak acids and weak bases, so molecular compounds. Here's a table that shows the strong acids, which you should start learning. You're not going to need it for your first exam, but you will have to recognize these by the end of the semester. Hydrochloric acid, hydrobromic acid, hydroiodic. You've learned to name those, and they ionize 100% in aqueous solutions. And here are some of those oxo acids that also, now you'll note that this indicates a back and forth. It's reversible. This is not strong, and I'm not sure why they, this is the strong one, this is weak. So here's some examples of weak electrolytes, weak acids. This is acetic acid, or basically vinegar. Weak bases, ammonia. We saw ammonia as an example of an electrolyte that partially ionizes in solution. And this is an indicator that we're dealing with a weak, my pen isn't working, sorry, a weak acid or base, that double arrow. A forward arrow only means it goes 100% to, or 100% ionizes or dissociates. This is only partial. So what you'll be doing is testing conductivity of two strong electrolytes and a non-electrolyte in your conductivity lab. So using your conductivity probe, you will make solutions and you will test the conductivity. You'll get a numerical value for that. And you'll notice the non-electrolyte, there's no light or conductivity that in that solution that will light that light bulb. When you have a weak electrolyte, partial ionization, you get a dim amount of light from that bulb. And when you have a strong electrolyte, 100% dissociation or ionization, then you get quite a bright response from that light bulb. So, can you classify the following as non-electrolyte, weak electrolyte, or strong electrolyte? So let's talk about these formulas. We have covered naming acids and bases, and the most common, well, strong bases all contain hydroxide ions. These belong to a larger class of compounds called ionic compounds. So, strong, this is a strong base. So it will be a strong electrolyte. This compound is organic. Anytime you see carbon, hydrogens, and oxygens in a compound, it's going to be a molecular organic compound. There are some weak organic acids and bases. However, this is a class of compound called an alcohol, and it does not ionize. So alcohols do not ionize. Thus, it would be a non-electrolyte. And you aren't going to be held responsible for weak acids. This happens to be a weak acid, so this would be a weak electrolyte. But you do need to be able to recognize non-electrolytes and strong electrolytes. And sorry, I wrote over the where those come in.